All right. Hello, everyone. Thank you for being here today. And on behalf of the Environmental Finance Center Network, welcome to our webinar on wastewater collection systems operations, maintenance, and inspection. My name is Kristen Crew from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or if you need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And on that note, we can go ahead and get started. I would like to introduce our presenter for today, Greg Pearson. Greg is a water and wastewater systems trainer coming to us from the Great Lakes Environmental Infrastructure Center. Welcome, Greg, and I will go ahead and hand it over to you.
Thank you, Kristen. Okay. Welcome everyone to today's webinar. We had a couple little technical difficulties on both of our ends here, but we're glad you're all here. Am I sharing my screen effectively now, Kristen?
It looks great.
Great. And I'm going to, when we start, I'm going to go off camera here so that you can, I'm hoping that helps you to see the slides a little better. So today's topic, I originally named this collection system operation and maintenance and inspection. And I think that's still an accurate name, but a lot of what we're doing today is we're talking about ways that we can focus our maintenance and repair and replacement efforts in the flow of our operational activities, partly, but also by conducting certain types of assessments. You know, water and wastewater infrastructure is underground, and it's not easy. It's not as easy to look at those assets as it is other things that are above ground. Pumping systems and so forth are above ground, easy to inspect. Collection systems are they're low pressure, and there are ways to inspect them. And we're going to be mostly looking at ways we can assess the condition of our infrastructure. So let's jump right into it here. Christian introduced the Environmental Finance Center Network. It's a national collaboration between individual environmental finance centers, and environmental finance centers are regional. Normally, the multimedia environmental finance centers, they have a regional focus. And I'm coming to you today from the Great Lakes Environmental Infrastructure Center, which is in the EPA Region 5, which is a 6-state region. that we primarily serve, but we're collaborating together with all the centers on a national EPA project where we can help communities. Primarily, our focus is communities that are smaller, less populations of less than 10,000. And what we do is partner with communities to help them increase their technical, managerial, and financial capacity. And Michigan Tech is a engineering university, so a lot of our focus is on asset management, and we can help you with obtain infrastructure funding and help you with compliance issues and so forth. My name is Greg Pearson, and the title they give me here is Water and Wastewater Systems Trainer. So let's jump right in, and I want to set the stage with a little scenario. So imagine you're a collection system operator who gets a call. It's 1 a.m. on a Sunday night, and on the other end of the phone, you hear someone telling you that there's an overflow system, the overflow situation. You have an overflowing manhole, and it's spewing out waste in the center of town, and you're receiving a lot of calls from customers who are experiencing even flooding in their basements, wastewater flooding. And so you ask yourself, what could be causing this? And as you prepare to look outside to check the weather, you reach for the light switch. So we're hoping to answer some of those questions today about how you could know what could be causing this type of situation, and what kind of things can we do to avoid things like this, backups and overflows. So the topics we're going to look at today, we'll start out by just discussing what are we really trying to achieve with the collection system? What are the goals? Well, what do collection operators do? And we'll talk about inspection and monitoring, some prioritization strategies, and then lastly, we'll talk briefly about some repair and safety concepts that we can apply. Now, as we're going through, we'll have some poll questions for you to engage. I know it's like a barrier between us, right, in this Zoom platform. I can't see your facial expressions, and you can't just easily ask a verbal question. But as you think of questions and even related comments that we can share with the rest of the group, please share. And I'm going to check in with you once in a while to see how you're doing. So we're going to do the best we can, and the polls also help to confirm that you attended in this platform. So the main goals of a collection system operator is to keep that wastewater flowing. Wastewater continually flows from homes and businesses, and there's things along the way that can stop the flow. If a lift station is not functioning, that can cause problems. If there's some kind of damage in the collection system or some kind of blockage, wastewater can stop flowing. So that being said, related task of the collection system operator is repair damage when it occurs, prevention of overflows, sanitary sewer overflows especially, prevent and manage inflow and infiltration, which we call I&I, and then always inspecting and monitoring to predict when problems could occur, and then taking proactive action to prevent them from occurring. So a sanitary sewer overflow means when sewers have some kind of backup or surcharge situation where the collection system is overwhelmed and the sewer is no longer remaining in the sanitary sewer system, but floods out, which causes problems with human health and environmental health. It's something you want to avoid. So to avoid those, we're looking at things like doing some studies and measurements to determine how much inflow and infiltration do we have. Is there any blockages, and how can we be proactive in removing things like grease buildup, debris buildup, and even roots that can come in through cracks and joints and cause blockage of flow, and preventing pump outages by inspections and regular maintenance. So the first thing that operators will do is have some kind of schedule where they routinely monitor. You'll see collection operators opening up a manhole and looking inside, and often you'll find in a collection system, you'll find that there's some key manholes, especially where different areas of the town come together, or certain areas of the town that have some issues that could cause problems. Like if you have a street that has a lot of fast food restaurants, and if there becomes an issue with some of the grease traps, that could be a situation where you start getting grease accumulation that could cause problems. A area of town that has more potential for having certain types of issues like rags being flushed, or disposable wipes that can clog pumps and cause problems with lift stations. So what the operator is doing is looking inside there and see, is there any unusual situations in the manhole? Is the flow deeper than normal? Is the rate of flow seem to be slowed down to a lower velocity than normal? And that would give you some indication that there's some kind of blockage. Now, the first area of study that we can do is we can look at the overall inflow and infiltration in our system. Now, there's inflow and there's infiltration. We'll start with inflow. Inflow is always the result of a deliberate connection. Something has been connected to the wastewater collection system that wasn't supposed to be connected. And usually that is when people have downspouts from the roof drains, and there could be additional water from sump pumps for pumping out basements. There could be yard drains, or even sometimes there's cross connections between stormwater lines that could all inflow and add extra water to the sanitary sewer. Infiltration, on the other hand, is water that's entering from the ground either through a defective pipe or a poor pipe connection or some kind of damaged manhole structure. And you could see in the images on your screen on the left, you can see a broken pipe structure. On the lower part of that image, you can see a crack, and actually a piece of that pipe is gone. And on the right-hand side of your screen, you can see a poor joint, and you can see the water actually pouring through. So those are examples of infiltration. It could be from groundwater. It might be that your collection system is actually at the level of groundwater, or perhaps the groundwater level rises during wet weather events. Now, you can actually conduct an inflow and infiltration study, and there's a couple of factors that help you establish the baseline. One is the average daily dry weather flow. To obtain that, you're going to the headworks of your wastewater plant normally, and you're looking during the dry weather, what is our average flow per day? Okay, so then you compare that. Obviously, you could compare it to wet weather flow, but we're going to start a little more basic than that first. So you have your average daily dry weather flow that's actually reaching the wastewater treatment plant, but then you have this concept called base wastewater flow. The base wastewater flow is the wastewater that's actually coming out of homes and businesses from indoor plumbing and entering the sanitary sewer system. And there's different ways to derive this. One is if you have a system where the indoor metering is separate from, for water, is separate from the outdoor water metering, then you could look at assuming that the indoor metering all eventually goes to the drain, the bathtub, dishwashing, toilets, showers. That should all end up going into the wastewater system. If you had an average daily dry weather flow higher than that, that means the water is coming from some other source, and that would be groundwater that's coming infiltrating in to the sanitary sewer system. So How do we determine the groundwater infiltration during dry weather? Well, we subtract the base wastewater flow from the average daily dry weather flow, and that gives us an idea of how much groundwater is entering our collection system. And here's an example. We go to the plant and we see that we have 160,000 gallons per day measured on our treatment plant meter. And our base wastewater flow is 150,000 gallons per day. So we subtract those two and we find that 10,000 gallons per day is entering as infiltration from groundwater. And that's a number that we could establish as a baseline, and we could track it over time. It also tells us that there's some level of pipe defects that is allowing some groundwater to come in. Some other concepts that we can look at is, one is the capture coefficient, and it tells you, it's a measurement of how much of the rain that falls on a certain area. So if you had a town that was 5 square miles and it rains a half an inch, so you'd have a half inch over 5 square miles, that would be the total amount of water. And what is the fraction of that that actually enters into the collection system? So that would be a good factor to know. If it's 1% of all of that water that falls, that's another piece of information that you could track over time. And of course, the relationship between rain flow and peak flows. How much, when you have a rainfall event, how much of that actually ends up entering into the collection system. So those are all factors that you can use to track inflow and infiltration, and then you can track the trends over time to see if either of those are increasing over time. The second source of information that we can use is smoke testing. And smoke testing, basically it's a method of blowing smoke down a collection system, a section of collection system pipe, and the smoke will be visible as it comes out of any escape route. And that escape route could be a crack or bad joint in a collection main, or it could be something that like a roof vent on a house where smoke should come out of. Here's an example of smoke testing in action. The photo on the upper left, you see the operator is there recording what he observes as the smoke test is being conducted. On the upper left, it looks like maybe there's either a broken lateral or some type of drains that are not properly capped in the lawn area. And there you can see the smoke coming out of them. On the bottom of your screen, you can see smoke coming out of a roof vent. And that would be normal because the vent is meant to provide venting to the actual sewer piping inside the home. And this is another reason why you want to notify people plenty of time ahead before you conduct a smoke test, because they're likely to think their house is on fire or the neighbor's house is on fire when they see that. And on the upper right, you see two operators that are placing a smoke testing device on a manhole. You see it's designed to fit right on a manhole, kind of seals on there, and it has a motor that will operate a fan to blow the smoke down the pipeline. And usually the heat of the exhaust is used to take the smoke liquid and turn it into a vaporous smoke. It's usually non-explosive and non-toxic for the most part. I don't think it's something you want to inhale, but it's not a toxic gas. It's meant to be a visible gas. When you actually conduct smoke testing, you'll want to isolate the section of pipe that you're going to smoke test. And so the image on the upper left shows a sewer plug being placed in, and it's connected to an air compressor. And so you insert the sewer plug on the section that you don't want smoke to go down, and you inflate it with the air compressor. And you usually have a release valve on that tube, obviously not down in the sewer, but you'll have it on that tube, the air hose, where you can release the pressure and pull the sewer plug back out when you're done. In the image on the upper right, you can see that they placed that smoke tester on top of the manhole, and that section of sewer is isolated with sewer plugs. And you can see that there's some smoke coming out of a crack in the main and some smoke coming out of a roof vent. So we've found one defect there that we might want to go back and look at with something like a CCTV. So you're using the sewer plugs to isolate the test volume. It's kind of like the step one. And there's another image of the front of that sewer plug. And you place the smoker on the manhole with the liquid smoke chemical, and then you view where the smoke comes out and record the results. So you'd have to have some kind of way to label where you're at. You'd probably go by street name and block, and probably use addresses to help you identify what section you're in. Manholes are usually about 400 foot apart. Sorry about that. I think I skipped a slide. So we're going to go to our first poll now, and we'll ask Kristen if she can bring that poll up.
All right, so the first poll question, you are conducting a smoke test and notice that smoke is only coming out of the roof vents of houses. What does this mean? Does it mean the smoke testing chemicals may have started a fire? The household plumbing has an illegal drainage connection? There may be a blockage in the collection system? Or the house is properly connected to the collection system? Looks like most people have answered, but I'll give everyone about 10 more seconds to go ahead and get your answers in. All right, closing the poll in 3, 2, 1. All right, Greg, so 75% of people said D, the house is properly connected to the collection system. And then we had a tie, 12% said the household plumbing has an illegal drainage connection, and another 12% said there may be a blockage in the collection system.
Okay, well, those are good answers. Thank you for participating. And the smoke coming out of the roof vent is actually normal. That's where smoke should come out. But there are other locations on a house where it would indicate an illegal or not recommended type of connection, and we'll look at that. Thank you for participating. I hope everybody's doing okay, and don't forget to put questions and comments in the chat or the Q&A if there's a Q&A available, and we're gonna be looking at those. And if there's a burning question, Kristen will stop me and say, hey, we have this question we need to have answered. Otherwise, we'll try to leave some time at the end to look at questions. Now, where that big arrow is, we've placed a smoke tester. We're calling it a smoke blower. And that smoke is going into a manhole there. And we see some sewer plugs that are isolating that flow. The black little mark, and it's labeled plug. So there's some smoke coming out of some different locations. First of all, there's a little bit of smoke coming out of some roof vents on the house, and smoke coming out of the cover of a manhole. The manhole covers usually have some holes drilled through the top on the standard type of manhole cover. Some manhole covers can be sealed if turns out to be a manhole that has a propensity to have sanitary sewer overflows, but most of them are just naturally vented. So smoke coming out of those, top of a manhole or roof vents, that would be considered normal. This next, where that arrow is, there you see some smoke coming out of a rain gutter. And that tells us that someone has hooked their rain gutters. So every time it rains, all the water that's collected by that roof is placed into the collection system. That would be a source of inflow, because it's due to a deliberate connection. And we have some smoke in lawn areas that could indicate we have an uncapped clean out or some kind of a broken sewer lateral. Sewer lateral meaning the connection that's coming from the home. And we see both of those situations there. We see one, there's a break and some uncapped cleanouts. Also, you might see some smoke along the sewer line between the manholes or on the manholes themselves that show that there's some damage. And we see some, on the far right, we see some damage to a collection pipe and some damage in a manhole. And those smoke coming out would tell you, hey, there's a problem here that you need to look at in some way. And the manhole might be, if there's a problem with the manhole, that would be as simple as opening the lid and maybe examining it from that direction. But if you have a smoke coming out along a collection system, buried main, it might need to be observed with some kind of a CCTV camera. And finally, we have a situation here. We have an interconnection with the green circle between the storm sewer and the sanitary sewer, some kind of cross connection. And there are systems that are called combined systems that handle both runoff, stormwater, and sanitary sewer. But in this scenario, we're talking about sanitary sewers that are isolated from storm runoff. Another way to assess the condition of our collection mains is through flow monitoring. And here we see a collection system pipe that's being monitored for flow. And right now what we can see is the sensor that is telling us how high the water level is in that collection pipe. And what you don't see right now, because water is over it, there's another sensor that measures the velocity of the flow. So what this flow monitoring does, it compares the velocity of the water to the height of the water. And that gives you information about basically how well water is flowing. Most collection systems, they're sloped between 0.5% to 1% slope. And they're designed to have a continuous but sufficient velocity. We're looking for somewhere between like right around 2.5 feet per second, 3 feet per second, something like that, where the wastewater can flow without allowing solids to settle out in the pipeline. High enough velocity to keep everything moving. But what you don't want to see is some imperfections or debris that causes damming up. So that's basically what the flow monitoring is looking for. And in this image on the right-hand side, you can see that flow meter that we couldn't see because the water was covering it up. So that's measuring basically the velocity of flow, and the upper sensor is measuring the height of the flow. And so if the depth is higher than normal for a given flow rate, it indicates there's something that's blocking that water. It could be the pipe that has a negative slope. There's some kind of a restriction. Sometimes pipes can drop at certain points along the pipeline, or some type of surcharge condition, or there's water entering from I&I or some kind of other source it's placing more water in that pipe all of a sudden at that connection. And if there's a lot of velocity changes, it can also indicate there's problems. Okay. Dye tracer studies, if you knew there was a leak, but you didn't know where it was, the dye can make it very visible. It's a fluorescent dye that would allow you to be able to see it with the right kind of lighting. And so you can see in this situation, that particular environment where you see the dye flowing down, that would probably be a very difficult area to see a leak without the dye. So it can make it visible, and that would be useful in certain situations to find out where a leak actually is occurring. This is one that that is kind of a underutilized piece of data, looking at repair records. As an asset, every asset has an expected life. Sewer pipes, like clay sewer pipes, there's a lot of them in the ground that are close to 100 years old. Certain types of piping can last a long time. But the thing of it is, when you have an expected life and you get to the end of the expected life, I mean, does the asset go from operating perfectly in one day and then suddenly the next day it's shot? It doesn't really work that way. What really happens is, as an asset nears the end of its expected life, you start having more problems with it. So one way to describe that process of deterioration that accelerates with time is the decay curve. It's conceptual, but eventually you get down to a point where you've reached the minimum acceptable performance level, and the asset either has to be rehabbed, like lining a sewer line would be a form of rehab, or replaced, putting a whole new sewer line in. So during that decay portion of the curve, you can expect to see an increase in breakdowns, more service calls, more repairs, a higher frequency of repairs. The thing of it is that makes it difficult is it's not like you're going to have all of a sudden having 10, normally you're not going to have like all of a sudden have 10 service calls in a year. It's going to be more like you have, one service call every 5 years and then 2 service calls every 3 years. So it's difficult to perceive that unless you have records that you can look at and graph some of these things. And then you can say, we can see that the problems with this certain lift station or collection main is increasing in frequency. So that gives us an idea that we need to take a little closer look at that collection main and see what's going on with it. What are the problems? Is there a problem with the joints? Is it deteriorating? Is it collapsing? So those are all sources of information. And the last one, and I've mentioned CCTV as a means to kind of as a second check when we find that we have greater inflow and infiltration in an area. If we find we have cracks from smoke testing, if our flow studies or flow monitoring shows us that we're having some problems with flow velocities or repair records, CCTV would be a good follow-up tool for those types of things. CCTV, if you're paying a contractor to do it, it's fairly expensive. And so small systems, one strategy they can use is to use some of this other data to do some targeted CCTV inspection. And if you don't really have anything to go on as far as those other pieces of information, you can kind of ease the cost by doing a certain percentage of your system each year. The CCTV is basically some type of little vehicle or robot that can be controlled from a van or some kind of other control device, and it basically drives down a sewer line and takes video of the sewer line, and you can observe it. It looks like this image here looks like this is actually a brick sewer, and it looks to be in pretty good condition. And the alternative to using data like this is to rely on something like age. In our asset management plans, we'll usually have an expected life. We might say, okay, this certain pipeline, we expect it to last 80 years. And so we're expecting at the end of that 80 years to replace the asset we're planning. I mean, it's good to have a plan, but it's even better if you can use some prioritization tools. And age turns out to not be a very reliable assessment tool. And an example on the screen here, on the left, you see a 30-year-old clay pipe, and it has multiple defects. It looks like it could even collapse. It's deformed. There's longitudinal cracks. It looks like some circumferential cracks as well. And it looks like it's going to be restrictive to flows as well. And we're on the right-hand side of your screen is a 100-year-old brick sewer. It does have some drops in the bottom there, but other than that, it looks like it's in pretty good condition. So which one would you prioritize? The 100-year-old brick sewer in this case, or the 30-year-old clay sewer that has so many defects? So it's a good idea to have some triangulation when you're thinking about what's going to be your maintenance strategy and what's going to be your operational strategy. And what you can do with some of that data is plan how you're going to deal with these assets. The criticality of an asset is basically the likelihood of it failing times by the consequence if it fails. So what's going to be the impact? A large trunk main that's collecting all the sewer from a community, and possibly going across highways and through the middle of town. If that were to fail, that would obviously be a high consequence. Where a likelihood of failure it relates to the condition of the asset. What kind of condition is the asset in? So if you basically you assign a 1 through 5, something like a 1 through 5 scale for each of these. So a likelihood of failure, if it's very likely to fail, might be a 4 or 5. If it's unlikely to fail, it might be a 1. And the consequence of failure will be the same thing, 1 through 5. So you multiply those to get an estimate for criticality. For high criticality, you would do immediate work. That would be your upper right quadrant, representing, say, for example, a 5 times 5. And so you'd have to take some kind of immediate action. It means operators are going out there and they're repairing or rehabilitating or calling a contractor in to reline it or replace it. We're on the other end of the spectrum, a very low criticality. It's very unlikely to fail, and it's a low consequence of failure, like a very small sewer line in a kind of a remote part of town that would only affect a couple of houses, would be a very low consequence of failure. And so those types of situations, you would probably just continue with routine monitoring and regular preventative maintenance like you're already doing. Now, if either the likelihood or the consequence is high, but the criticality is still not high, you can have a plan to more aggressively monitor and maybe provide some targeted maintenance depending on what the problem is. So that's how some of these pieces of data relate to our operation and maintenance. You can also have some criticality weighting. In other words, you look at the likelihood and the consequence of each asset. And in this case, where assets would be sewer main sections, lift stations, within your collection system, pumping stations. And larger pipes and force mains that are carrying, a lot more volume would receive a higher criticality rating based on this criteria. And it makes sense, right? Because if you have a very large wastewater main, if that breaks and fails, there's a lot more wastewater that's going to be released. One caveat though, you may have very large pipes that are oversized just because the community was expecting a build out at some time in the future. So that might not justify a higher weighting, but this is one way based on the quantity of flow. Another way is to look at how this collection system component would affect transportation or business. Here's a image here of a wastewater main that broke, and it released 15 million gallons of sewage into a river. That has more to do with our next slide, but the point here is it disrupted a major thoroughfare for traffic and impeded people's access to businesses. And so people trying to get to work, people need to go to the doctor, even emergency vehicles need to travel on this route. Well, they can't. If there's an emergency vehicle that needs to get to a house to save somebody's life, they have to go around because the entire transportation system was disrupted in this area. So that's another factor that you could use to have criticality weighting. Sometimes a small pipe can cause just as much disruption as a large pipe with transportation issues, because you still have to dig up the roadway to get to it. Also, criticality weighting, based on environmental impact, and that has to do with how near are sewer lines or force mains to sensitive waterways, or how near are they to critical populations, such as hospitals and schools or any densely populated area. So that would have a greater impact in those areas. You might have two mains that have exactly the same size and the same potential to fail, but one is in a densely populated area near a school and hospital, and another is in maybe like an industrial area. Well, the one that affects more people would have a greater criticality rating. And the image that you're seeing here on your screen is a force main break that had occurred in Florida in 2019, and it ended up releasing 80,000 gallons of wastewater into a sensitive creek. GIS is a valuable tool to help you kind of overlay the sewer system and population areas and sensitive waterways. So it provides a way for you to analyze these types of situations and help you to plan an operation and maintenance approach, and an approach to maybe monitoring. This could give you information about where should we use our CCTV, where should we conduct smoke testing, where should we conduct flow testing. So that would help us to make those intersections between sewer lines, transportation lines, and other weighting factors. So let's go to our poll 2, and I'll allow Christian to bring that up. And I'll read it in the meantime. Which of the following criteria would increase the environmental criticality of a water main? As you're answering that poll, I want to check in and see how everyone's doing. If you're hearing and following along and benefiting from the presentation, let us know. If you're having any difficulties, let us know as well.
All right, it looks like most people have their answers in, but I'm going to go ahead and give everyone about 10 more seconds. All right, closing the poll in 3, 2, 1. All right, Greg, so we have about 3/4 of people said collection main is adjacent to a vulnerable body of water. And then we also had a couple others, second place with 10% of people said video inspection shows evidence of root intrusion. Truck main is installed under a major interstate, and then also collection main crosses below the path of a water main.
Well, under the major interstate, that could be, I can see how that could also be something that could affect people. But I would categorize that under the transportation criticality. And collection main crosses below the path of a water main. That's the standard way to do it. To have the wastewater below the water main. But answer A seems to match the best with the environmental criticality. So if you're near a vulnerable body of water, you want to think about how a sewer problem, overflow or break, could impact that water. Do we have any comments or anything about how everybody is receiving the presentation so far, Kristen?
Everyone, it looks like only compliments so far. All good, doing good, going great, interesting stuff. You're doing a great job, hearing well and able to participate. Thank you.
Good, that's good. Thank you for that feedback. That really helps a lot. Thank you, Kristen. Here we have some inside look of a CCTV setup. The gentleman on the left is in a control van, and you can see that van or the truck on the far right. It's like a little office, and the person is recording the video, observing the video, and also controlling the device. So if he or she sees some kind of a defect, they can actually back up and look a little closer and move the camera around and look. And so this particular one is they've named their little robot a mud monster. I got to talk with a company. I was in Idaho about a month or so ago, and I got to talk with a company that designed these things, and they were telling me how the wheels on that mud monster type device can be changed according to the size and type of the main. So there's some adjustment that needs to go on to make sure that you have good traction and good control of the vehicle as it goes through. But this is CCTV, and basically you're using a camera and a remote controlled device to visually inspect. And here's some examples of some images that show different kinds of damage. This particular one was borehole damage. Somebody was boring probably for a sewer connection, and they went clear through the pipe and kind of went too far and drilled into the opposite side of the pipe. And this is a couple of images of grease buildup. On the left-hand side, you can see some grease building up on the bottom. And on the right-hand side, you can see that there must have been a very full pipe and allowed grease to adhere to the top. And here's some images of roots coming in through cracks and joints. Looks like that one on the right it's almost blocking the entire flow. So one way to get rid of roots is with a sewer cleaning truck, but sewer cleaning trucks the purpose is to clean debris and grease out, but they do have root cutting attachments that can remove roots. And the combination sewer truck, it has the vacuum hose, a jetting hose, and it can also be used to do cleaning on lift stations. You spray them down and vacuum them out. So basically how they do it, they insert the jetting head upstream in an upstream direction from one manhole to the next. And then as you turn it on, you pull back in a downstream direction and pull the hose back towards you, and it cleans in the direction of gravity, and then use the vac truck to remove the debris that you pulled to the manhole. So you do it from manhole to manhole. And this is the picture on the upper right shows you the jetter in the direction of flow. We're pulling it backwards, and it's removing grease and debris. And the image on the bottom shows the vac truck backed up to a sewer main, and that the jetter is on the blue line, and it's going to pull you see the pile of dirt there at the manhole. It's pulled that debris there, and then the vac part is drawing that and putting it into the truck. And that's the direction that the head would flow. Some other things that operators routinely do, collection operators, it's pretty important because heavy loads, if you have a manhole that's too high, heavy loads like trucks can actually cause some problems. It could actually end up breaking the main, cause cracks. So usually it goes the opposite direction. Usually you have to raise them because the road department will come in and overlay the road, and it makes it higher, and you have to raise the manhole up. But the idea is for it to look like that one on the lower left that says Baltimore County Sanitary Sewer. That seems to be pretty much perfect. It's perfectly level, so you're not going to have any impact when tires roll across it. And you can see the sewer rings there, the cement sewer rings on the extreme left bottom that you can use to put in there and adjust them. There are some different products now that make it a lot easier to usually you have to take off that metal part of the manhole cover and place rings under it and re-concrete them in. There are some easier systems out there now. When you're making repairs, you have a lot of safety issues. You have traffic safety. You're often working out in traffic. You also have excavation safety. Excavation safety is one of the most dangerous. One of the biggest excavations are one of the greatest causes of injuries, according to OSHA. And any trench that's over 5 feet deep, you need some kind of a way to make that trench more safe, whether it be shoring or some kind of shielding, or shoring or sloping. Also, when you're making repairs, you often can use sewer plugs to isolate the flow. And if you have to go inside for some reason, operator has to go inside, you can also use plugs to help reduce the hazards of engulfment and sewer gases. And there's lots of different hazards in a collection system. Collection systems can be one of the most hazardous places to work because you have confined spaces and in lift stations. So we did a class a couple weeks ago on lift stations. There's electrical hazards, unsafe ladders, so a lot of hazards. And particularly confined space hazards have a potential to have toxic or explosive gases. So you have to have a gas meter that checks for things, for toxic gases like hydrogen sulfide, conditions of either oxygen deficiency or enrichment, which oxygen deficiency means there's not enough air to support life. Enrichment means it could support flames or fire. And basically, to protect yourself from confined space gases, we're continually monitoring the atmosphere with a gas testing device, but we're also ventilating, and we want to ventilate at least 12 continuous air changes per hour at that rate, or 60 intermittent changes per hour. And I didn't give you this information in this presentation yet, but I'm gonna use this as kind of like a random Jeopardy type question. Which of the following statements about hydrogen sulfide gas are correct for poll 3? And Kristen will bring this up. And we're going to be ending shortly. Which one of the following statements about hydrogen sulfide gas is correct? I kind of gave it away by using the word "are," right?
All right, it looks like most people have their answers in. I'm going to go ahead and give everyone about 10 more seconds. All right, closing the poll in 3, 2, 1. All right, so most people said E, all of the above. It's going to be 87% said E, all of the above.
That's good. And you know, the important thing to look at here, it's true that hydrogen sulfide gas is explosive at 4.3% concentration. That would be equal to 43,000 parts per million. But just because it's not explosive doesn't mean it's safe, because at only 100 part per million, it can result in death if you enter that. And it does smell like rotten eggs, but it disables your sense of smell in just a short time. So all of the above. And one thing I want to mention is, it's when you're dealing with safety, there's a concept known as the hierarchy of controls. At the lowest level, you're using personal protective equipment to protect you from danger, where at the highest level, you're eliminating the hazard altogether. So that's something to think about when you're looking at collection systems. And something like a lift station, that I mentioned this before in our lift station training, but you see that gentleman that is entering that lift station on the right, having to go into a confined space and have safety equipment and so forth, that's a hazardous endeavor. Whereas you could redesign your system to have something like a dry well, where there's still hazards, but the hazards are a lot less. And you want to always make sure you work smart when you're out there and working in collection systems. A lot of dangers, and we have to be familiar with our personal protective equipment. When you enter into a manhole or any confined space, you have to have a gas monitor. You need safety equipment, and you need the partner system to keep you safe out there. We're not really doing a safety training, but I want to remind you to keep your safety equipment calibrated and inspected, that when you're conducting inspections of the collection system, it's just as important to inspect your tools and your safety equipment on a regular basis. Make that part of your routine. So what can we conclude? We want to establish an inspection program to monitor an asset collection system, piping and assets, some kind of way that will help you establish priorities and help to direct your operational and maintenance practices. And you want to be proactive, preparing ahead of time for emergencies like main breaks and situations that require safety protocols. And you want to do some testing to look at the integrity of your mains and determine things like what is your inflow and infiltration and how is it increasing over time if it's increasing. And then, of course, I think you would all agree with this. We want to facilitate a continued learning and infrastructure improvement practice in our utility. And by the fact that you're all here today engaging in this webinar, and you guys have been great. I know that you're doing this already in your utilities, and we're a little bit over time. I apologize for that. But if you would like to, I encourage you to share something you enjoyed learning about today in the chat. And we're also open for questions. And as you're doing that, I want to recommend that if you're looking for infrastructure funding to improve your collection system or your wastewater treatment system or any part of your utility, you can use the Environmental Finance Center network funding guide. All you have to do is go to that link at the top, or just go to efcnetwork.org and find the funding tables. It's one of the links at the top of the page, and you click on your state, and it will give you all the state and federal funding sources available to you, and even has contact information and tells you what it takes to be eligible. And if you want to contact the Environmental Finance Center, you can find the TA request form and ways to contact any of the centers by going to efcnetwork.org. If you'd like to contact us here at the Great Lakes Environmental Infrastructure Center, we're at gleic.org. And if you would like to send me an email for any reason, you ask a question or something of that nature, I'm at gpearson@mtu.edu. So I'm going to be quiet for now, and if there's anything coming into the chat that you can share, Kristen, feel free.
Thank you, Greg. So we do have quite a few questions, and I think what's going to end up happening is we'll have Greg follow up with your question via email. There are a couple of repetitive questions that I want to go ahead and ask. And again, if you don't have the time right now and you need to log off, feel free to go ahead and log off. We will get back to you. But one question that I did see a couple of times was regarding using root be gone as a preventative for roots and the collection line.
I really can't, I don't have any personal experience with it. What I know that people that end up doing, they end up cutting the roots out and then repairing the crack or the joint so that the root can't come in. I would assume that the root be gone would work, but cutting the roots out and repairing the pipe is probably a much more permanent solution. However, if you want to send me an email on that, or if your email is included on the question that was asked, I can do a little bit more research on it. I'd be glad to do that.
Great. And then the next question we'll go ahead and address right now. How does a high water table affect smoke testing?
That's a good question. It's a good question. I know it still works because in the system that I kind of grew up in as an operator, we had a high water table and the smoke testing worked. It might even result in the smoke being forced upward even at a better rate. I know it still works, but I've asked the same question myself, and I've never heard anything about the smoke testing being disrupted by water. We had, in the town I grew up, in as an operator, we had a 5-foot water table, 5 foot below the surface, and smoke testing worked just fine. But I'd be happy to look more into that as well.
Great. Thank you so much, Greg. And just to repeat myself one more time, we will follow up with you if you sent in a question and we didn't have time to address it. I will send those to Greg personally, and we will make sure that your question gets answered. And a huge thank you to Greg for sharing his expertise with us today. Following this webinar, each of you will receive a follow-up email with the slides from today, as well as a link to the recording to this webinar. We also ask that you please complete the webinar evaluation so you can let us know your thoughts on today's session. This helps us plan future webinars on topics that are important to you. Thanks again, and we hope to see you at future AFCN events. Thank you, Greg.
Thank you, everyone. Thank you, Kristen. Have a great rest of your day, everyone.
You too. Thanks.